Okay, Precast students, in this video we'll be looking at systems of equations that have three variables, okay? Systems of equations that have three variables. Now, we just finished looking the other day at systems of equations that have two variables, okay? But now we'll be looking at systems of equations that have three variables. Go ahead and copy this heading down in your notes if you would, please. Your heading for today is systems with three variables. Systems with three variables, lesson 14.2, and be sure and include today's date in your notes, okay? Systems with three variables, lesson 14.2, and be sure and include today's date. Now, let's start off by looking at what one of these systems looks like, okay? You can write this down if you want to. You don't have to, that's up to you. And really, to be honest with you, this should be material that you totally went over already in Algebra 2 2 years ago during your sophomore year, okay? But here we go. This is what we call a system with three variables. Notice I have three variables, x, y, and z, okay? So what we have here is a system of equations that has three variables. Now understand, the three variables do not have to be X, Y, and Z. They can be A, B, C, or any three letters that you want. Okay? Alright, moving on. Now, notice that we have three unknowns, X, Y, and Z, which is what I just said, okay? So moving on. Sometimes a system will be given to us in a special form, like this form right here. Please copy this down in your notes. Here it is. Okay? Copy that down, please. X minus 2, y plus 3z equals 9, y plus 3z equals 5, z equals 2. Now understand, this is still a three variable system, since we obviously still have three unknowns. And you say, well, Mr. Earhart, there's not three unknowns in this equation. True, there's not, but in the entire system, when you add up all of the unknowns, we have an x, we have a y, and we have a z, so we still have three unknowns. However, when a system is written in this form here, it is amazingly easy to solve, okay? And by the way, this form is called row echelon form, okay? Row echelon form. Let's solve this system, and you will see how easy it is to solve a system that is written in row echelon form, okay? Here we go, take some good notes. Well, in a problem like this, we already know what one variable equals. Z equals 2. Our goal is to find out what x equals, y equals, and z equals. And we're 1/3 of the way done. Now, look at this equation here. We only have two unknowns, a y and a z. So where z is, I'm going to substitute 2. So y plus 3 times 2 equals 5. Y plus 6 equals 5. Bring the 6 over and make it negative. 5 negative 6 is negative 1. So now I know two variables. We're 2/3 of the way done. Now I'm going to take my y, negative 1 and 2, and put them in here for y and z, and solve for x. So x minus 2y, where the y is, I'm going to put negative 1, plus 3, and where the z is right here, I'm going to put 2 equals 9, okay? Now let's solve for x. Negative times the negative is positive 2. Positive times the positive is positive 6 equals 9. X plus 12 equals 9. Sorry about that, guys. X plus 8 equals 9. Bring the 8 over and make it negative, and we get x equals 1. So there we go. Now you do know the right way to write your answer, okay? X comes first, then your negative 1, then your 2. Now, Mr. Earhart, what if we didn't have x, y, and z? What if we had a, b, and c, or a, h, and p? You always put your answers here in alphabetical order, okay? Alphabetical order. So x comes first, then your y, then your z, okay? Alright, if your three unknowns were b, g, and x, b would come first, then g, and then x, okay? Alright, so notice when a problem is written in row echelon form, it is really, really, really easy okay? And understand I will not be giving you many of these, okay, on a test or a quiz. Alright, moving on. Now, what if the system is not written in row echelon form? How do you solve it? Well, good questions. Let me give you some steps that will help, okay? Here we go. First of all, you want to come up with two equations that have only two variables, okay? I will teach you how to do that in just a couple minutes. Make sure, however, that these two equations that have two variables, make sure they have the same two variables. In other words, and yes, I do know how to spell variables. That was a mistake there. But anyways, guys, what I'm saying is if one equation has an x and a y, make sure the other equation does not have a y and a z. You want both equations to have an x and a y, or both equations to have, a y or a z, or an x or a z. But whatever you do, make sure that both equations have the same two variables. That's really, really important, okay? Okay, continuing on. Step 2. Take these two equations that have two variables and solve for one of the variables like we have learned how to do in the past. And then step 3, once you know the value of one variable, the rest is pretty easy, okay? Alright, let's go ahead and continue on. Sounds exciting, right? Not really, but let's go ahead and solve one of these. So here we go. I'll pause for a minute while you copy this in your notes. And if you totally remember how to do this from Algebra 2, please feel free to work ahead, okay? If you want to watch me, that's fine also. However you want to do it, okay? Go ahead and copy this in your notes and let's solve this linear system, or this three-variable system. Okay, students, here we go. Now, first of all, you have to choose which variable looks the easiest to get rid of. Now, for me, I think the y's look really easy because they're all 4s. So if I could just make this 4 here a negative and do some combining, I could probably get rid of the y's the easiest. So I'm choosing to get rid of my y's. So remember, step 1 was come up with two equations that have how many variables? 2. So I'm going to choose to get rid of my y's. So my two equations will have x's and what else? Z's. Okay? Now you might choose to do it differently, and that's fine, okay? But I'm going to get rid of the y's. So the first thing I'm going to do is I'm going to combine these two equations here. Now why would I do that? Because one is a positive 4 and one is a negative 4. Okay? So watch what happens. 2 plus 2 is 4x. These cancel. Negative 1 plus 2z is positive 1z. 7 minus 6 is 1. So look what I did. I'm now accomplishing step 1. I have one equation that has two variables. So pull it off to the side. Now, don't forget which two equations you added. You don't want to add those again, okay? At least not now. So I added this equation here and this equation here. Now look, if I add this equation here and this equation here, look, I've got a positive 4 and a negative 4. So that'll work just fine, okay? So here we go. I'm going to add the top and the bottom equation. X plus 2x is 3x. My y's cancel. 1 plus 2 is 3z. Equals negative 6. Okay, so there's my second equation. Now to be honest with you, remember I've taught you guys, you can reduce equations. Before I pull this equation over here, let's reduce this equation. Divide everything by 3. That's a lot easier to work with, okay? So there we go. Now you don't have to do that, okay? You do not have to do that, but I think it's easier to reduce for equations. So I very easily accomplished step 1. I have come up with how many equations? 2. Both of those equations have how many variables? 2. And notice they're the same. 2 variables, okay? XC, XC. Well, we know how to solve these. We learned this the other day. It looks like to me the easiest letter to eliminate would be my Z's, okay? So I'm going to take this equation here, and I'm going to multiply a negative 1 through to make this C become negative 1. So my top equation stays the same. And my bottom equation becomes negative X, negative Z, positive 2, okay? Combine, I'll get 3x. These will cancel, and I'm left with 3. Divide both sides by 3. X equals 1. So there's part of my answer. Okay, I'm 1/3 of the way done. Now, take your 1 for x and put it in for x over here. It can be any of these equations. I'm going to use this equation here because I have some room to work. So here we go, where the x is here. I'm going to put a 1. So 1 plus z equals negative 2. Bring your 1 over, make it a negative 1. Z equals negative 3. So there we go. Now, we know what two variables are. So you can put a 1 in for x and a negative 3 in for z. In any of these equations, this one looks like the easiest one because there's no variables in front of the x and the z. Now you could use any of these. I'm going to use this one here. So x, that's a 1, plus 4y, plus z equals 0. So I have 1 plus 4y, positive negatives, negative 3 equals 0. Combine your like terms. 4y, negative 2 equals 0. Bring your 2 over and make it positive. Divide by 4. 1/2. So there's your y. 1/2. So you'd write your answer like this. 1 comma 1/2 comma negative 3. Okay? There we go, not too difficult. Now I want to show you guys something. This is a pretty easy problem because all of your y's had 4s. Don't forget that sometimes you're going to have to multiply equations by numbers. For example, let's say I chose to eliminate my x's first. Well, I could go through and change all of these signs here. And combine this equation and this equation. And that's fine. That's a good thing to do, okay? However, next, I would want to combine probably this equation here and this equation here. So to get rid of the x's, I would have to multiply this top equation by what? Negative 2. Because the negative 2 here cancels with the positive 2 here. So sometimes you will have to multiply a number through or a negative sign through or both in some cases, okay? Alright, moving on to the next problem now. Like any system, sometimes there can be no solution, and sometimes there can be infinite solutions, okay? So you need to know that. So, let's solve a system that has no solution, alright? Here we go. Copy this down, please. I'll give you just a minute to do that. Copy that down, please. Okay, here we go, students. Alright, now, which variable does look like it'd be the easiest to get rid of? Probably the x's, because I have a 1x, a 2x, a 1x, all of that. So, I'm going to slide these over to get a little bit of room to work with. Okay, students, here we go. So personally, I'm going to eliminate my x's, okay? So I'm going to take this top equation and this bottom equation, x and x, I'm going to combine them. But first of all, I'm going to multiply this top equation here by a negative 1 to get rid of all the signs, okay? So here we go. This would become a negative. This becomes a positive. This becomes a negative. And this becomes a negative. Now let's add the top and the bottom equation. So we're going to cross this off here. And here we go. Your x's cancel. Positive 3, positive 2 is a positive 5y. Negative 1c, negative 3c is a negative 4c. and a negative 1, and a negative 2 is a negative 2. Alright, so there is my equation that has two unknowns. Alright, now we got to do this again and get another equation. So here we go. Okay, we just combined the top and the bottom. So let's combine the second. Let's combine the top and the second, okay? So I need a negative 2 right here. So I'm going to multiply this entire top equation by a negative 2, okay? So here we go. Negative 2 times x is negative 2. Negative 2 times negative 3 is a positive 6. We'll make that a 6, okay? Negative 2 times c here would be a negative 2c. Negative 2. And negative 2 times 1 would be a negative 2. Negative 2, okay? So I'm going to take the top equation and the middle equation and combine them. Let's get rid of this so we're not confused. And here we go. Combine these, your x's cancel. Positive 6, negative 1 would be 5y. Negative 2, negative 2 is negative 4. And then negative 2 and 2 would be 0. Okay, so there's my second equation that has two unknowns. Okay, so we're doing pretty good. Now let's go ahead and solve one of these for a variable. Now, I'm looking pretty good here. I mean, I've got a 5 and a 5, negative 4, negative 4. All that I have to do is multiply this top equation by a negative 1 to change all the signs, and I should be okay. So let's see what happens here. This becomes negative, this becomes positive, this becomes positive. So here we go. These cancel, and you're left with 0 equals 2. Okay? Well, students, we know as soon as that happens, we know the answer is no solution. No solution. Okay, there we go. No solution. Okay, so sometimes these systems will have no solution. Alright, I'll remember, sometimes they'll have infinite solutions, okay? So let's now take a look at a system that has infinite solutions for its answer, okay? Here we go. Alright, go ahead and copy this in your notes, please. While you're copying that, I'm going to go ahead and try to move this over to get a little more space, alright? Go ahead and copy this in your notes, please. And here we go. Now, students, notice I have something here that's very interesting, okay? Notice I have an equation that has a y and a z. And I have an equation that has an x and a y, okay? So I'm doing okay. Really, what I could do is just take this equation here. If I add it to this equation here, look, students, watch. What's going to eliminate my x's, right? Sure. So my x's will eliminate, and I'll be left with an equation that has a y and a z, which is what I want, because I have an equation here with a what? A y and a z. So that's the route I'm going to go, okay? So here we go. I'm going to cross this off for a second. X's cancel. Y plus 2y is 3y. Negative 3z plus nothing. There's nothing here like a 0 is negative 3z. And negative 1 plus 1 is 0. So there we go. There's one of my equations. We'll slide that right over here. Now, notice, students, I have one equation with a y and a z. And look, I've got an equation here with a y and a z. In fact, look, I can very quickly solve for y or z. I'm going to multiply this bottom equation here by 3 to give me a 3, actually a negative 3. So I'm going to multiply this bottom equation here by a negative 3 to give me a negative 3y. So here we go, okay? top equation stays the same. And multiply your negative 3y through. And look what happens, students. Everything cancels out. So as soon as that happens, you know the answer is infinite solutions. Now if you did your homework yesterday and you learned how to write infinite solutions with the letter A, then you should be okay. Alright? You need to write your infinite solutions with the variable A. Okay? Let me show you what I mean. Watch. Okay? Go to your two equations over here that we started with right over here. Okay? Let me be very clear, students. It doesn't matter which equation you go with, okay? It doesn't matter. But here's what please listen to me. Here's what you always do when you have infinite solutions. Please listen to me. Here's what you always do. You solve the equation, okay, for y, so you get y by itself, and you want z over here. So if you have an equation that's x and a y, that's not going to cut it. You have to come up with an equation that has a y and a z. Let me say that again. Please listen to me carefully. Take good side notes. Listen, anytime you have an answer that comes up to infinite solutions, when you're dealing with systems like this, then you need to get an equation that has a y and a z. Okay? Now, you want to solve for y. And that's the first thing you do. So, I don't care which one of these you take. I'm going to use this one because it's easier. Okay? I'm going to take this equation and solve for y. Bring the z over, it becomes a positive z. So there we go. Now, always for z, you put a. Okay? So now, if z is a, right here we're going to put an a for z. Then what does y equal also? A. Now, how do I find out what x equals? Well, I feel like I'm going too fast. Let me pause and back up and go over this again. Anytime you get out infinite solutions in your answer, the first thing you do is take one of your equations that has a y and a z. If you don't have one, get one, okay? Then you get y by itself. After you get y by itself, you always put a in for z. Now, why the letter A? Well, every textbook is different. I have taught out some textbooks that do not use the letter A, but a lot of textbooks do, and this book does. So we're going to use the letter A for Z. So after you put the letter A in for Z, then you have A for Z right here. And then for Y, you have whatever you have Y equals. In this case, it's A. Now sometimes it'll be A plus 2, okay, or something like that. Then right here for Y, you would put A plus 2. Okay, let me show you what I mean. Sometimes you'll have an equation like this. For y, 2y minus z equals 6. And you'll solve for y like this. Divide by 2. That's a z right there. Like that, okay? So you got y by itself like you're supposed to. And then for z right here, what letter do you put? A. So what does y equal? Well, y would equal 1/2 a plus 3, or 3 plus 1/2 a. So that's what you would put here for a. So it's not always going to be a here and a here. Not always, okay? In this case it was, but it's not always going to be like that. Okay, so we know what z is. We're going to call it a. We know what y is. It's a. So now all that we have to do to find out what x is we pick any of these equations. It doesn't matter which one. I'm going to use the top one. And for x, I leave it x. For y, I put what? Well, y is a. So plus a. Minus 3. Z. Z is a, so put an a. Equals -1. Now combine your like terms, and we have x minus 2a equals -1. Bring your 2a over. X equals -1 plus 2a. So now you know what x equals. Now usually you write your a term first, so I'm going to put 2a 2a minus 1. However, if you want to put negative 1 plus 2a, I have no problem with that, okay? That's totally fine. So students, there's your answer. There it is. You did really well, okay? That's it. So you only do this when you have infinite solutions, and I've given you 2 of these in your homework tonight to practice on, okay? Alright, moving on. Alright, now I want to end with a thought and an example. The thought is this, and you can write this down if you want to, it's up to you. In order to solve for multivariables, you must always have as many equations as you have variables, okay? In other words, if you have 2 variables, you need 2 equations. If you don't have 2 equations, you can't solve the problem. If you have 3 variables, you need to have 3 equations. If you don't have 3 equations, then you can't solve the problem, okay? Now, sometimes you will be given a system in which you don't have enough equations to solve for the variables, okay? Obviously, in these situations, you can't solve the problem because you don't have enough equations. However, you can write an answer in terms of A, like we did earlier, right back here. Right back here. When we had infinite solutions for our answer, we wrote our answer in terms of A. And by the way, what does that mean? That means if you gave me a number for A, like 3, then my answer would be 3, put a 3 right here, 5. So 5 comma 3, 3 is one of the solutions for this problem. Give me another number for A, 2, okay? Put a 2 here, put a 2 here, put a 2 right here, 4, you 3. So 3 comma 2, 2 is an answer, is one of the infinite answers to the solution here, okay? So you can use that same idea. You can write your answer in terms of A like we did earlier when we have a system with infinite solutions. Alright, let's look at one of these problems. Let me show you what I mean, okay? Copy this problem down, please. There it is. Copy this down. Now while you're copying it down, notice we have 3 variables. So in order to solve this thing, we need 3 equations. And we don't have 3 equations. We have 2. Okay? So there's no way we can solve this with numbers. However, we can write it in terms of what? A. Now here's how you do it. Remember earlier, way back when we were writing our infinite solution problem in terms of A, I told you, you always want to have an equation that has a what in it, do you remember? I hope you guys were listening. You always want to have an equation that has a y and a what? Remember, z. And then get z by itself, okay? Well, or get y by itself, excuse me. Well, if I want to have an equation that has y and z, then I better get rid of my x's. So I'm going to multiply this top equation by a negative 2, okay? So here we go. I would have negative 2x, positive 4y, negative 2z, negative 4. And then my bottom equation would stay the same. 2x minus y minus z equals 1. Okay? Now let's go ahead and combine these. These cancel. 3y minus 3z equals negative 3. Okay? Now let's go ahead and reduce this so we have smaller numbers. We can divide all of these by 3. So y equals y minus z equals negative 1. Okay? There we go. So look what I have. I have an equation with a y and a z, like I've taught you to do. Now get y by itself. There we go. Now what else have I taught you to do? Once you've done that, what do you put in for z? Remember, you put the letter a in. So y equals negative 1 plus a. Now what did you put in for z? A. So far in your answer, we have what for z? A. What do we have for y? Y equals negative 1 plus a. No, I'm going to write it the correct way. I'm going to put my a term first. A minus 1. However, if you put negative 1 plus a, I have no problem with that, okay? That's fine. But technically, it's proper y is supposed to look like this. Now, guys, look. All I have to do is solve for x now, right? So I don't care which equation you use. I'm going to use the bottom one, okay? I have 2x, then minus what? Y. Well, what is y? A minus 1. Minus what? C. What is C? A. So minus A equals 1. Let's do some simplifying. Take your negative sign, multiply through. Negative times A is negative A. Negative times negative 1 is positive 1. Negative times A is negative A equals 1. Okay? Now, combine your like terms. You have 2x minus 2a plus 1 equals 1. Okay? Now get x by itself. So bring this term over and bring this term over. So you're left with 2x equals, bring the 2a over, becomes a positive 2a. When you bring this 1 over, becomes a negative 1. Combine it with a positive 1. They cancel out, so you really have plus 0, okay? Which you don't have to put. And now divide both sides by 2. X equals a. So put an a right here. There we go, we did it. So, what does this answer do for me? Not a lot, but what it does shows me that I can pick a letter for A and get out a order. This is called an ordered triple, by the way. This is called an ordered pair, like 2, 5. This is called an ordered triple because we have 3 numbers. So what I can do here is I can pick a number for A, get out an ordered triple that satisfies both equations. Let me quickly show you what I mean. Let's just pretend that A was 5. We can pick any number we want. We're going to say that A is 5. So 5 minus 1 is 4. And put a 5 here for A. So Mr. Error, you're telling me this ordered triple right here satisfies both equations. Sure, check it and see. Put a 5 here for x, 5. Put a 4 here for y. Negative 2 times 4 is negative 8. Plus 5. And why is that not working? Hold on 1 second. It should work. Let's see here. Let's see. I'm concerned now, students, that maybe during all the work that we did, I made a mistake here somewhere. I hope that I did not. Okay, but either way, I won't. This is supposed to be here a representation of the ordered triples that satisfy this equation here. Okay. And I'm not sure why it's not working, but trust me, it does work, and that is what this does for you. And if you don't, if you're kind of wondering, does Mr. Hart know what he's doing, you can try it in your homework, and you'll see if you get the answer correct, that when you put the numbers in, pick a number for A and put it in, this order triple will satisfy the equation up here, okay? And I'm not sure why it's not, but anyways, that's it, guys. I hope this video has been a help to you. If you have any questions, don't